Okay, so here's the last part about adding, subtracting, multiplying decimals. And like I do a lot of times, what I want you to is think back to your own, lessons or learning of doing this. And what I want you to do, as we do this a lot, copy down each problem. So not just the number, but copy down each problem and tell me which one is the easiest to the hardest for students. So maybe not for you, but for your students, which of these 8 do you think would be the easiest? And put that at the top of your paper. And which would be the hardest? Now here's the thing. You do not have to solve these. I don't care about you solve them. We're going to go through them here in just a minute. So don't necessarily solve them. Just rank them. Write down the problem, the easiest problem to the hardest problem. And it is very important to write down the problem. And I'll explain why in a little bit. So don't just write like 4, 2, 8, 7, 3. Write the actual problem down. And then don't solve it. And then I want you to also think about how you would solve it. So if I asked you to solve it, what do you think you would do? What are some terminologies you would use? What are some things you would say to yourself, or maybe even out loud, whatever? And the last one, question I have down here is, so for this number, what is the most important digit in this number? Okay, so of those digits there, which is the most important digit in all 5 of those digits? Okay, that's it. And then so go ahead and press pause, and then we will come back together and chat a little bit more. Okay, so hopefully you had a chance to write down those problems easiest to hardest. I'm going to go ahead and show you my ranking. I'm not saying my ranking is correct. This is just based on, knowing students and what I think they would struggle with versus not struggle with. I'm going to go and give you my ranking, and it's going easiest to hardest. Now, you will notice that I actually didn't write down the entire problem, and I'll explain again why as we get to it, but I didn't want to give you a little hint here on why that's important. I just wrote down the numbers. Okay, so the first easiest problem is number 2, and that was 0.49 minus 0.35. That's definitely going to be the easiest one. The vast majority of students will get that problem correct. All right, so that's definitely an easy one. The next easiest problem is, a little bit more room down here at the bottom. All right, the next easiest one is number 8, and that was 12.7 minus 6.9. And some of you might have thought that maybe that wouldn't be so easy for students because they'd have to borrow, but actually that's not too bad. For the majority of students, borrowing a number is not that big a deal. There is one little tricky thing on that problem that might slow them down, but I think that's probably the second easiest problem. Okay, number 3 is everything else. All of the other problems are hard for students. Everything else students make mistakes on. So look at that, right? Look at that issue. And again, your top students don't have issues with any of them, right? Your medium students don't have issues with hardly any of them. But your bottom students, the students that struggle in math and end up hating math, they're going to have trouble with all the other problems that I put on the board. So it's kind of interesting, I think, that that of all those that are there, most of them are going to be difficult for kids. And most kids think that decimals are easier than fractions, and yet we have all these problems that I think students struggle with. They make mistakes. They think they're doing it right, and they're not. And as we talked a lot this semester, that's kind of an issue. And then the last question was, which digit is the most important digit? And the number 2 was the most important digit. So the number was 23.749. And the number that has the biggest effect on this number right here is the 2. If you change any other number to something else, it doesn't change the value very much. But what I mean with that is you change this 2 to a 3, right? You've changed the value of this number a lot. So that's just changing it by 1 digit. You change the 3 to a 9, you haven't changed it nearly as much as you did if you change this 1 digit to a 3, or this digit to a 9, or that digit to a 0, right? So these digits don't affect the number nearly as much. And again, that's going to place value. We want kids to understand the numbers on this side have more influence on the value of this number than the numbers over here. If they can get that, then the next couple of lessons I'm going to teach you guys are going to be much simpler for them. Okay? All right, let me go and pause it one more quick time here and get set up. Okay, so now we're going to do some algorithms where we're adding and subtracting decimals. All right, so I'm going to put a problem on the board here, and we're going to take a look at it and talk about it real quick, and then see what happened. Okay, here's my problem. 0.5 plus 0.3. All right, so 0.5 plus 0.3. So I'll give you a second to write that down, and then I'm going to ask a question, and I want you to think, or you can say it out loud if you don't mind people thinking you're a weirdo by talking to yourself. What's wrong with that problem? What did I do wrong? There's something not right about what I did. And if you think back a minute ago, I asked you guys to write down those problems, not that you ranked, not just the numbers, but actually write down what each problem was. And this is what I was getting to. I'm guessing that many of you wrote these problems down just like this when you wrote the problem. And this is not good for students. So if you haven't figured out what's wrong with this yet, it's this. Okay, so we need to have that 0 in there if we want students to do this the easiest that they can. But part of the reason I teach this the way I do is because not everybody writes in those zeros. In fact, I would argue the vast majority of us, and I say us, meaning me too, don't write those numbers in there. And I pretty much only do it when I am teaching to somebody else. But when I'm doing my own calculations, I don't write in that 0 because I understand there's a 0 there. When I'm teaching it though, I always put the zeros in. And so, okay, so let's talk about this then. And I think if I were to ask you guys, what do you remember doing? How do you remember doing this? Or what do you remember being taught? And a lot of people are probably going to say something like line up, right? Does that sound familiar? Line up. You remember your teachers telling you to line things up? I would imagine you did, because that's a very common way of teaching. And I think the rest of that would be line up the decimal points, right? So that's what we would do when we're adding and subtracting decimals. We line up our decimal points. So I have 0.5 like that. And then I'm going to line up my decimal point. So I have 0.3 like that. And then I can add. So then I add 5 plus 3 gives me 8. And then I bring down my decimal point, and 0 plus 0, of course, is 0. So that's probably how most of us remember doing this problem. It's not how I teach it. I used to teach it this way. But I'm going to put a problem on the board that's going to show you why that way is not awesome, and why that terminology is going to be confusing for some students. You're going to say that line up your decimal point, line up your decimal point, line up your decimal point, and they're not going to know what you're talking about because they don't know what you're talking about. So let's take a look at a problem here. Like say, for example, this one. And what you might notice is if our terminology is to line up the decimal point, your low students are confused because they don't see a decimal point in this problem. You know why they don't see a decimal point in this problem? Because there ain't no decimal point in the problem. It's just the number 7, right? So that terminology is going to be confusing because this problem they will come across quite a bit. And nobody, just like we don't ever write 0.5 as, ourselves, we also never write this 7.0, right? Nobody does that. If I'm writing down the number 7, I write down the number 7. I don't write down 7.0. So I have tried to teach this and get kids to understand where the decimal point is. I thought I have come up with some ingenious ways to help them remember it. I even bring in English because, English students think English is easier than math. So if you're going to write a sentence, where do you put the decimal point or the period? And they say at the end of the number, right? And all this different ways of trying to teach it to them, and they get it when I'm teaching it, and then in the calculation, nothing. They always forget where the decimal point is. So I will tell you, or I will show you what my students will do for this problem. My most struggling students are going to do this problem just like this. They're going to go 7 and then plus 4.32. Because forever, when we have done adding problems, we've always lined up these numbers over here. And the reason we did that before is because we didn't have any decimals. They were all whole numbers, so it made sense. Those were going to be the ones digit, whatever number. If it's a 0, that's in the ones digit. But here, we're not talking about that. This is not the ones digit. That is the ones digit. And so this is what your struggling students will do, and they'll come up with the number 4.39. So let's think about what they're doing here. They're saying 7 plus 4 basically equals 4. 7 plus 4 equals 4. Clearly, that does not make sense, right? 7 plus 4 does not equal 4. Again, it goes back to what's the most important number in the, or digit in this number. And the 2 is not that important. The 2 is tiny. If we're talking money, that's pennies. This is dollar bills, right? So which one do you care most about? If the cashier screws up this number and only gives you one of those back, but screws this number up and only gives you one of these back, which are you more mad about, right? So this is very insignificant. This is way more important. So this is basically 7 plus 4, which should be close to 11. And that's what I have my students do a lot. I have them estimate. So when they do this, they're going to tell me first, okay, what basically is this number? 7 plus 4.32 is basically 7 plus 4. And I don't even care if they round this or not. They can just drop them off. I just want them to look at these first numbers. Basically, it should be close to 11. So if they do this, then go, wait a second, what happened? Why isn't that right? Okay, so this is not what I do, right? Because if you say line up the decimals like this, so line up the decimals, that's what we did up here. Okay, that's no good because lining up the decimals, there is no decimal for this one. So I don't want to do that. I only want to use words that are always going to be utilized or be in the problem. So I'm not going to say line up the decimals. I say line up the whole numbers, because you'll always have a whole number. Like I said, we don't ever write down these zeros, right? But do you know who does? Teachers and textbooks and tests, right? So every test that they take, every textbook that they look at, and hopefully every teacher they have is always going to write down those zeros so that I can see that I have 0 whole numbers. But no teacher or textbook or test is writing down 0.7 just so you can see the decimal place. They are never doing that. So I'm going to use words that are going to work for all problems. So if I say line up my whole numbers, there's always going to be whole numbers in this. It's going to be 0 in this case. So now if I get to this problem, 7 is a whole number because there is no decimal with it. So all right, so that's 7, and then plus 4.3. So plus, well, 4 is a whole number, and then 0.32, and there you go. Now they have lined up their whole numbers, and then they have whatever's left. I actually don't care if students go 0.00 if they want to. Most of them do. They like that. They like to see that, okay, I have the same number of decimal place, whatever, but they don't have to. Literally, this problem is 7 plus 4 is really what we're doing here. So, okay, I go 2, I go 3, and then 7 plus 4 gives me 11, and then it should be pretty close to 11, so 11.32, okay? Literally, that's adding and subtracting. The only difference subtracting is you do this and you do this, and then you subtract it. So the way I teach adding and subtracting is exactly the same. It's line up the whole numbers. Line up the whole numbers. There's always going to be a whole number written. There's not always going to be a decimal written. And I have tried a billion different ways to try and get my students to remember where the decimal is, and they just can't remember it. Most of them can, like I said, most of them are fine. But that bottom group, they struggle. And if you got to say line up anyways, might as well use the rest of the phrase. It's going to work for all problems. So for adding and subtracting, what I say right here is line up the whole numbers. All right? And there's no issues with that. No matter how hard the problems get, it's always going to be able to line up the whole numbers. Okay, so that's adding and subtracting. Like I said, the algorithms don't take very long. They're pretty slick. Now we're going to talk about multiplication. Okay, so multiplication. Let me put a problem on here for you. Actually, I'm gonna do one more question here that I like to give these little questions. Which of these is easier? All right. Which of these is the easier problem? Is this one easier? Or is this one easier? Okay, so is 4.2 times 2.7 easier, or is 52 times 135 easier? Well, I know what I think you're thinking, right? And I know what I think most students would be thinking. Most students are saying this one's a lot easier than this one, because I don't know what these decimals got going on over here. This one doesn't have any decimals. I know how to do that. Bam, I can go do my area model or whatever it is that I want to do for my multiplication. It's easy, I can do it. These decimals, who knows, right? So, and I agree, this one is easier than this one. So what I have students do, if they don't know what they're doing, what they might think is, oh, line up my whole numbers, line up my whole numbers, line up my whole numbers, which is the mistake a lot of students make. So for adding and subtracting, we line up the whole numbers, but for multiplying, we don't. We are going to do what we did for adding and subtracting a little bit. If you remember, what I did over here was I estimated. I said that this is basically 7 plus 4, and 7 plus 4 is basically 11. That's exactly what I do over here. What I never do is have my students count decimals and then move decimals. We're going to do a couple topics where you guys are used to like counting up decimals and moving left, or counting up decimals moving right. I never teach that. In my own head when I was a kid, I don't know if it's because of my dyslexia or what, but I struggled with knowing if I was supposed to be moving left or moving right. It didn't make any sense to me what my teachers were telling me. So I'm going to go ahead and show you how to do this problem without ever telling a kid to count decimals or to move left or right. What we're going to do is we're going to place the decimal in the exact right spot. Okay? So here's the first thing that we do. The very first thing I'd had my students always do was estimate. Okay? So estimate. And I don't even care how good they are at estimating. I want them to know that this number is basically, if you want to round this to 4 and round this to 3, 4 times 3 gives me 12. So it's going to be super close to 12. Okay? As close as I can make it to 12 as I can. If another kid is really bad at rounding and they never understood how to round, so they say, well, I don't really know, but I think it's 4 times 2, which is 8. You know what? Good enough. That is going to be close enough. The way I teach this, 8 is just as good as 12. Okay? So once they've done this, once they've estimated, and I don't care how they estimate, they could drop the decimal and multiply their whole numbers, or they could actually round that to a whole number and then multiply. This is going to be a little bit closer, but this is going to be close enough for what we need them to do. So the first thing they do is estimate. Then the next thing they do is multiply without decimals. Okay, because we just said that the problem that did not have decimals was easier than the one that did have decimals. So all I got to do is multiply these numbers. So I'm just going to multiply them any way that I know how. I don't care how they multiply them. Just multiply 42 times 27. They want to do the area model? Awesome. They want to do left to right? Awesome. They want to do the lattice? Awesome. I don't care. Just multiply. All right. So I'm going to go ahead and multiply this the way that I know how. Go back to my olden days. 29. Hopefully I'm doing this right. And that is 8. And then I add these and I get 4 and 13 and 11. Okay, so now I've multiplied this and my answer that I came up was 1,134. Okay, that's what I did. When I multiplied these together, I got 1,134. But that's clearly not the right answer, because we already know that my answer needs to be super close to these two numbers, 12 and 8. So all I have to do is put my decimal point in to whatever spot is going to get me closest to 12, if that was my estimation, or 8. So if I put my decimal point right there, I got 113.4. Is that close to 12 or 8? No, I don't think so. If I put it right here, I got 1.134. Well, that's closer than 113 is, but I don't think that's very close either. if I put it right here, I now have 11.34. And 11 clearly is pretty close to 8, and 11 is also close enough to, 12, and then it's close enough to 8 as well. So that's what I teach them. I say estimate first, that's going to get you close to the right answer. And you estimate it by multiplying this number times that number. Good enough. Then multiply without decimals, because that's a lot easier math problem. We already know that. It's a lot easier problem. Then go back and put your decimal point in anywhere you think it'll go so that it's going to be closest to 12, that was your estimation, or 8. All right? Okay, we're going to do one more example of multiplying, and then that's it. Then we're done. Okay. All right, so there we go. 10.4 times 2.03. Okay, now, first thing is we want to estimate. So 10.4 times 2.03 is basically 10 times 2, which is pretty close to 20. So my answer had better be super close to 20. Now I get to multiply this using any method that I want. It's going to be 104 times 203. So I got 12, 3, I got 0, 0, 0, and I got 0, 0, and I got 8, 0, 2, and add all these up, and I get 2, 1, 11, 1, 2. So I've got 21,112. And then my last thing is put my decimal point in so it's closest as I can get to 20. And I see that the place, if I put it right here, it's 210, that's 2,000, that's 2, but right there is 21.112. So the answer is 21.112. And that is how I teach multiplication of decimals. All right? So I never have them count. I never have them move. There's a lot of issues with that. They don't know if they're moving left or moving right. So instead, I said, let's just talk about what this is. This is 10 times 2. Let's all agree this is basically 10 times 2. 10 times 2 is 20. So I do my math. I get this crazy number. Where could I put that decimal so that it's going to be closest to my estimated answer? And that's my answer. Okay, so that's all decimals right there. All right, so we did all the showing and we did all the algorithms, and there'll be a little bit of homework tonight, and then well, hopefully I can get the homework posted tonight, and then we will see what happens for next week. Okay, have a great weekend.